Hello student. So let us start our discussion. In previous lecture we have discussed introduction of basic computer. So in this lecture we will start our discussion with stored program organization. So let us start our discussion. Let us see that what we are going to discuss today. So let me start today's discussion. So here we will try to understand very basic computer. Now, as you can see in the figure, a basic computer, it consists of CPU, then RAM, and then you can say auxiliary memory. So right now we will not try to focus on auxiliary memory. Okay, we will consider only CPU and RAM. Now, what is the meaning of stored program organization? Now, in stored program organization, the data will be stored in register in form of pattern of 0100, means any binary pattern. Okay, so then there will be obvious question that what will be this binary pattern and what is the meaning of it. Okay, so let me tell you that what is binary pattern and means what is need of this binary pattern and how it will be used by computer. So there will be two important term uh, in this video. So the first one is instruction code. Okay, and another one is operation code. So what is instruction code and what is operation code? Let us try to understand. Instruction code is nothing but combination of operation code plus operand. Then we will have a very obvious question that then what is this operation code? Operation code is nothing but pattern of binary number. Pattern of binary number or binary digits which will specify some operation. Means operation code will tell computer to perform certain operation. Now it will be combined with the operand and then we will have an instruction code. So what is instruction code? Instruction code is nothing but combination of operation code and we can say operand. Now next thing, I hope you have understood this. So let us start our discussion. Let us move forward. So what we are going to discuss into this video. So let me start with the first question. So in this video we will try to cover following mentioned question. So first of all, what is the difference between content and address? Now CPU cannot execute all the instruction at a time. So CPU will retrieve the content from RAM one by one, and then it will be executed, then next instruction will be fetched, then it will be executed, then next instruction will be fetched, then it will be executed. So CPU will execute all this instruction one by one, so we can say it is serial execution. So how CPU will retrieve the content from the RAM? So to retrieve the content from the RAM, CPU have to specify the address. Now here you can see this numbers represent the address. Okay, so if CPU want to access any content of RAM, first of all CPU has to specify the address. Then using that address, CPU will retrieve the content, it will execute it, and then again if CPU want to store result into the RAM, then again CPU will use the address. Now address will only specify the location of RAM. On each location there will be some data. We can say there will be some binary data like 0 1 0 1 1 0 0 1 1 1 likewise. So this binary data is known as content. Okay, so dear students, remember whenever you want to access any content of RAM, you have to specify the address. Now just for your understanding, if we have two location, okay, then how many address bit will be required? Only one. Address of first location will be 0 and address of next location will be 1. Now if we have 4 address, then how many bit will be required? We will require total 2 bit. Okay, why? Because 2 raised to 2 4. Okay, so if we are having n location, then number of bit required will be m. Okay, so m will be total address bits. Clear? So if we are having 1k of RAM, okay, similarly if we are having 8 location, then how many bits will be required? 3. Then if we are having 512 location, then how many bits will be required? 9. Okay, and for 1k location we will require 10 bit. Similarly for 1 mega location we will require 20 bit, and for 1 giga location we will require 30 location. Okay, so if our RAM size is you can say 8 GB, okay, so then 30 bit will be required for giga location, and addition to this, okay, we are having 8 GB, so additional 3 bit will be required to specify a location into the RAM. Okay, so total how many bit will be required? 33 bit. 33 bit will be required for 8 GB RAM. Okay, so if we are having 16 GB RAM, then we will require 34. Then if we are having you can say 32 GB, then we will require 35, likewise. Clear? So while CPU will use the content of any location, CPU will specify the address in form of binary. Okay, this is just for your understanding that I have written this address into the decimal. Otherwise this address will be represented into the binary. Clear with this? Okay, so we are done with our first question, that what is difference between content and address. So I hope you people are now clear that now if I say that we are having 4 KB of RAM, okay, then how many bit will be required? 10 bit for 1K, 11 bit for 2K, and 12 bit for 4K. Okay, so here the total number of address bit required to specify a single memory location into the RAM, it will be 12. And on each location, let's assume that we are storing 16 bit. Okay, now group of 8 bit is known as byte, and group of 16 bit is known as word. Okay, so what is our RAM size for basic computer? 4096 into 1 word. Okay, so we can say 4K word. It is our RAM size. So we can store 4096 different word into this RAM. Okay, now again let me clarify you that don't get confused with this 16-bit and this 12-bit. This 12-bit are for address and this 12-bit represent the data. Clear with this? Okay, so let us continue our discussion. So next question, after learning it, how computer will address the memory? Okay, so this question we have discussed. Okay, what is difference between content and address? Next question we have discussed how computer address or it addresses or it will use the content, so that we are going to discuss now. So whenever computer will try to use this content, there are two possible method. Okay, the first method is direct method and second method is indirect. Now what is direct method and what is indirect method? Okay, so before starting the discussion with this, what we can say here, if this is CPU and this is the RAM of primary computer, then 12 bit will be required for address and 16 bit will be the size of data. Okay, so we will require two separate set of wire to carry the information. Okay, so one set of wire, or we can say bus, will carry the address and another set of wire will carry the another information. Okay, so we will require two bus. So the bus which will carry the information, okay, it is known as data bus. Okay, and the bus which will carry the address, it is known as address bus. Okay, addition to this, in computer we will also have control bus. Why control bus? Because we are having data and we are having address, but how we will specify which operation is going to be performed? So that operation means operation related detail will be carried by control bus. Okay, so that we will discuss in microprogram control unit. Clear with this? Okay, so let us start our discussion. Okay, so in RAM size of primary computer is 4K. Now how computer address the content? Now here you can see this is the 16-bit instruction. So here, as we have discussed, 12-bit we will use for address. Why? Because our RAM size is 4K. This MSB, or you can say last bit, we will use it for addressing mode. Okay, so 12 plus 1 13, and how many bit left? Total 4. Oh, sorry, 12 plus 1 13, and how many bit left? 14, 15 and 16. So 3 bit left. So these 3 bit will specify operation. Now if we assume this is a RAM, okay, means this memory. Here I have written, or I have drawn this like, so we can say that this memory grow continuously downward. So what is the instruction on location 10? 0 add 2 to 1. So this will perform the addition of memory location 2 to 1 into the accumulator. Okay, so what will happen? First computer will retrieve this instruction. So first memory reference will be required here, then using second memory reference, or computer will try to retrieve the operand, or it will retrieve the operand, and then it will perform the addition, and then again answer will be stored into accumulator. Okay, so what this will do, simply it will perform the addition of operand which is stored on memory location 2 to 1 with the accumulator, and again result will be stored into accumulator. Now, so If the MSB is 0, okay, most significant bit is 0, that means computer is directly addressing the memory location 221. Now what will happen in indirect? Now as you can see, 12 bit we will use for address, here we will use MSB for mode, and 3 bit we will use for operation. As you can see, the size of instruction is same in both the instruction code, okay, but here the value of MSB is 1. Okay, so let us understand what is the meaning of this. So whenever computer will fetch this instruction using first memory reference, then it will detect that this is the value of this bit is 1. So instead of treating this as an effective address of operand, computer will treat this as a address of operand. Okay, so address of operand. So it will go to this location, then rather than treating this 235 as a value, it will treat this as a address. Then computer will again go to the memory location 235, it will retrieve the operand, then it will perform the addition with the accumulator, and then again it will be stored into the accumulator. Clear? Okay, so here you can see first memory reference was for retrieving the instructions, second one was for retrieving the effective address of operand, and third one is for retrieving the actual operand. Okay, so here how many memory reference were required? Only 2. Here how many memory reference will be required? 3. Which method will be faster? This will be faster. Why? Because we require only 2. Which will be slower? This will be slower. Which memory, which addressing method will allow us to access the larger memory? This indirect will allow us to access the larger memory. Why? Because here I have specified address using only 12 bit, okay, but here on this location I have stored 16 bit, so using this 16 bit I can address the 16 bit of memory. Okay, so direct will be faster and indirect will be slower, but direct will have less memory address. Why? Because we are using only 12 bit, while indirect will have larger memory address space. Why? Because we are using 16 bit to specify any operand. Okay, so here we have discussed how computer address or use the content, means using the instruction, and what is the merit and demerit of various addressing mode, means how direct mode or how direct addressing mode will work and how indirect addressing mode work, and then we have tried to differentiate the both the instruction. Next command, next thing. Okay, how computer will send the command. Now here in answer to this question we will try to understand that how computer will start execution. Okay, so whenever any content will be retrieved, first it will be decoded into the IR. Okay, what is IR? IR is nothing but instruction register. Okay, so here as we have seen, this will be loaded into the instruction register, then here there will be opcode, and then here it will be address. Okay, so first of all computer will try to decode this opcode, so it can have idea that which kind of operation is supposed to be performed, and then it will try to understand the addressing mode. Then so computer can have idea that directly operand should be retrieved, or we should require one additional memory reference, and then using address CPU will try to access the content. Okay, so once CPU will retrieve this operation, or you can say it will decode the opcode and retrieve the operand, it will perform the operation, and then it will continue with the next instruction. Okay, another terminology that you should consider is effective address. Here 221 is the effective address of the operand, while in this case 235 is the effective address of operand. So how we can define the effective address of operand? Address which will specify the actual physical location of operand inside the memory, it is known as effective address. Okay, so in this session we will keep up to this. In next session we will discuss more. Thank you.